Welcome, everyone, to the Refrigeration Mentor Podcast. So excited that you're here again. Really appreciate you taking the time to listen, as always. We're always trying to uplift the industry, have guests here who has been there, done that, what we do day in, day out in the field for many, many years as technicians, business owners, designers, manufacturers. And today I have Art Sutherland. Art, I've really learned about you years ago. I've heard your name because I work with lots of people in Western Canada. And then you've been like a pioneer in the ice rink industry for a long time, because I think that's your bread and butter in the industrial side. And we'll get into your history because I want to learn more. But I know when I was looking up your profile, you started in the mid 70s, and then you start your own business. And I think around 1990. And my first question is going to be is like, what made you decide to go from a technician, because you were in there working in the field, doing the stuff, install, service, and maintenance? What made you decide to start your own business?
Well, I think from very early on, I was quite entrepreneurial. Even when I was in trade school in the 70s, I was able to go out and get work on the side and kind of learned on the way. Why I really wanted to open my own business is I love to travel, and I didn't want to have any restrictions upon me of where I got work. And I just kind of brute force and ignorance just stumbled along and picked up one job after the other. That our location is southern Vancouver Island, actually where we are, south of the America-US border, or the Canadian-US border, so very close to the US. And a couple of our first jobs were just south of the border into Washington State, and they kind of went well, and Oregon wasn't far away, and then California was below that, and one thing kind of led to another, and we started doing probably 60% of our work in the US, traveling all around. And as I mentioned, I love travel. I have 4 daughters at home, and I didn't want to abandon my daughters. So one at a time, I would take them out of school and they would come traveling with me while we were doing work as well. And I've had my 4 daughters and my wife on every continent, working with me and even helping with installs.
Love that.
Kind of a really cool story. Years ago in 2005, we got a job through the Canadian Embassy to refrigerate a castle in Italy, and it was going to be used as a pellet for a art exhibition in ice, where they were doing abstract artwork in ice. And for my kids, it was like being on a Harry Potter movie set, where we'd walk across a drawbridge and open a castle door, and we refrigerated this monastery in this castle, and it was just so much fun for them. And they said, "Can you take us to more jobs?" So we basically, by the end of it, ended up working on every continent, doing lots and lots of projects. So the love of travel is why I opened my own business. As far as good planning, getting into refrigeration, it wasn't a well thought out plan. It's just I had a friend of mine who said he thought this really cool course he was going to I might like. And through school, I existed through high school, but it wasn't a passion, anything that was happening there. But when I got into technical school, I think having great teachers just makes a huge difference in people's lives. And this guy just inspired me, Kenny Leadham, and had so many great stories of the places he's worked and stuff like that. And I thought, gosh, this is perfect for what I do. So I fell in love with the course and put everything into it, more into it than I ever did through my school years, and did quite well in it, and ended up getting hired right out of trade schools. And that was 45 years ago.
No, I love that. And what's cool about it too is like your first gen, it sounds like, you know what I mean? Nobody knew, nobody talked about refrigeration around you except this one person that introduced you to refrigeration, same as me. The cool thing is that it sounds like it continued to grow on you. And then as you developed and you got more knowledge, and then you start your own business and you include your family and you travel around, refrigeration really took care of you. And this is what I talk about with the technicians that are coming up. That's one of the reasons why I got into 2 things, is that I can make good money. Somebody told me, because I had no clue about refrigeration. And the second thing, that I learned I could travel the world, because I wanted to go and live in Australia. And because of refrigeration, I went and lived and worked in Australia because of refrigeration. Wow. So, you know what? And this is what I keep telling, whatever you want to do, if you get into refrigeration, you can do it. It will help find and guide you. I do have a couple of questions because I have a lot of technicians who reach out to me from around the world, and they ask questions like, I want to work in another place. So maybe it's them as a technician. It could be as a business owner. Do you have any advice for technicians? Just say if they're in Australia, they want to come to Canada, or they're in UK, they want to go to South Africa, wherever it is. You know what I mean? Do you have any advice? Because you worked in all these continents. You worked in Asia, you worked in Africa, Europe, Australia, New Zealand, all of them, right? What is some advice you could give them to try to make that move?
The safest method, especially contracting, is to find a good local contractor and partner with them. This from the business perspective, that they already have the licensing, they have the certification in that country. And very often in a lot of these places like Saudi Arabia, there's not many ice rink mechanics over there in Saudi Arabia. So you're bringing them an opportunity and you can teach them when you get in there. So for them, it's a win. They're learning from you a whole new sector of the business they might not have been exposed to. So just as you're doing with the education, if you can bring education to people, they love it. It just makes them a better company. So we never want to try to eat out of another person's rice bowl, like take work from people that they could have had themselves. But if you can bring the opportunity to them and show them how you can make their project better by partnering with you, that works really, really good.
I love that. And I think that, thank you for sharing that, because that is so, so important. You want to build good relationships. You want to build good partnerships. And it's really bringing that expertise and that knowledge to other places that don't really have it. Because I've had a lot of people right now, a lot of people in the Philippines taking my courses because there's a lot of big changes happening around the world. They're coming in taking the courses because they see natural refrigerants moving in there. And then this is happening in other countries as well. Right now, we know the US really moved with the AIMS Act, just started back in January 1st, right? So these are new regulations where manufacturers are, on that curve, or they're understanding them. But a lot of the contractors, a lot of them aren't ready or don't know about it, where you have to be invested. So different countries around different worlds, like say in Asia or in Africa, different places where we can, or you can take that expertise there. I love that, Art.
Yeah, that's a good thing.
Some of the things that, so that's for on the business aspect as a contractor. Any thoughts on, as a technician, some of the things that they could do? Because I'm sure you've hired people, you got a team, you work with, you got technicians on your team and stuff. Any tips that you would know or that you could share for a technician's point of view, or would you know?
Yes, I think they can help themselves get work a lot easier if they've got really good handcraft trade skills. And there's a lot of courses available today that are entry-level courses where they learn to use all the power tools. They learn how to braze copper. Here in parts of Canada now, you actually have to have a ticket for brazing copper. So getting a ticket for brazing copper, being able to put pipe in place and have it look really neat, having all those trade skills. So when they get into a van, they're actually helping the journeyman right from the get-go. That is really, really important. But being enthusiastic, showing up in the morning, not standing still when there's nothing to do, grab a broom and clean up. Just do anything you can to make the job easier for the people who are around you, being organized, setting out all the materials by sizes. So when the journeyman's asking for a part, he can go find it right away. Just simple things like that really make a person marketable.
Yeah, no, I agree with you for sure on that. And we could dive into that a little bit more. But one of the things is, let's dive into a bit about how your organization evolved. Because once again, you were a technician in the field for over 20 years, and then you started your business.
Yes.
So let's talk about that, because you made that transition. You wanted to travel the world. So congratulations on that. But I know for sure, over the 35 years you've been in business, you evolved, because that's why you're still in business. You continue to change and evolve, because back in 1990, refrigeration, the fundamentals is the same, but rules, regulations, laws, things have changed over the last 35 years. What are some of the things that you've seen since you either been in the industry or since you started your business evolve, and what are you looking forward to in the next coming years?
I think some of the biggest drivers that we've had in our industry are the climate. That's a really big one that we didn't know what the ozone layer was back in the 70s, had no idea of the problem. So the ozone layer, and then global warming was the next one. Now we're hearing TFAs being a problem. So being aware of what refrigerants are going to be around in the future is really important. Energy costs is another one that has a really big impact on the industry. Especially in the ice rink industry, they're not a high profit venue. So trying to keep the energy costs down and using a very efficient refrigerant. And that's only half the equation. The second half in venues is heating them, using heat for dehumidification, using heat for snow melt pits, using heat for underfloor, comfort heating. And there's no more efficient method of heat than using a heat pump. And your refrigeration system, no matter what the size, is a heat pump. So that gives you a lot of opportunity as well. And the last thing that's had a big impact is changing rules and regulations. That here we have our BC authority, and then we have a national authority, and the US has their own, more state by state sometimes in the States than what we find here in Canada. But the regulatory agency has made changes and prohibited some refrigerants from being used inside of buildings. The chart that you've got up there starts with CO2, a couple of the new ones, 1234 ZE and YZ, 513 and 449, which have lower GWP, but not low enough for states like California anymore. But now we're going to have to get under 150. Propane is not new. It's been used for years and years. And we used to use it in the gas fields in Alberta many years ago, and it just kind of went by the wayside. But now it's become a good option for having low GWP, no ozone depletion, quite efficient if you look on the COP side of the things. And then ammonia, which is very, very efficient, but we can't use it everywhere. There's some municipalities, for instance, I work for the International Olympic Committee, and the last Olympics in China, we were not allowed to use ammonia at all. But luckily, we got CO2 in half the venues and 449 in the other half the venues. So knowing the regulations is very, very important because they change depending on where you are working at.
Yeah, and I think that is super key. I do have a question for you too, because what you said earlier because you do a lot of refrigerations. I've had some people reach out to me that work at local rinks. We're talking about small towns. I'm in a city here, in Brantford. We got 100,000. Toronto's not far, so it's not hard to find a contractor here. But I have people in the US and different countries, even here in Canada. When you have a small town in Canada, we got lots of rinks everywhere because we're a hockey country.
Yeah.
But there's not many technicians being able to work on these anymore. And I'm having people reach out to me that they're a small community. They're like, I got an ice rink. I don't know how to get our stuff repaired because it's costing so much more. Do you have any advice for some of those owners of those hockey rinks? Because that's something you're in the world of.
Sure. Most of the rinks years ago were always ammonia, but not all communities actually had ammonia mechanics. And then the regulations required they had certified operators on board the rink as well. And that became an expense to them. So in situations such as that, we went with synthetic refrigerants, such as the 513 and 449. And although it's not as efficient and probably long-term global warming is not as good as ammonia or CO2, that it was really the best choice for them. So as far as finding a mechanic, if you can find a good grocery store mechanic or a good commercial refrigeration mechanic, they have a fighting chance of working on a system with 449 or 513. On the CO2 side, that there's some wonderful heat reclaim attributes with CO2, and it is going to be a growing force without a doubt, but not every local mechanic is capable of working on it, just like ammonia on the in. So somewhere there's got to be a middle ground that you have to make sense with the system you're installing, that you have the people local that can actually work on it.
Yeah. And I think the biggest thing too, and I don't know, maybe you can correct me on this, the generation of like, there's HVAC technicians around the world. There's lots of them because air conditioning is for some reason more important than refrigeration. Sometimes it seems. Mm-hmm. Then we got commercial refrigeration techs. Then we got supermarket techs. Then we got industrial techs. And it seems like there's less people getting in industrial refrigeration compared to, supermarket, but there's even less in supermarket versus commercial refrigeration, and then less in commercial refrigeration versus like HVAC or air conditioning. What are your thoughts and the trends you've seen over the last, say, decade in that? Is that something you noticed around the world as well? It's hard to find industrial mechanics versus a supermarket mechanic versus a commercial refrigeration mechanic?
Yes, and I can't verify this figure, but I've been told in the U.S. that they're short 600 industrial refrigeration mechanics right now, that there's just a big need for it. There's not that many companies in every town that do industrial. It's more of a regional business where you'll have one major player who might do a whole state or a whole province, where commercial mechanics, the threshold of entry is much lower. They can work out of their garage and go work on the corner store, walk-in coolers. But there's not enough industrial work for one guy to service one plant in one town very often. So you are right. It is harder to find the industrial. Just as the commercial market was turning inside out because of the Freon regulations and the global warming and the ozone depletion, the same thing is happening with ammonia. And it's more being driven by the safety aspect, that there's an awful lot of pushback from various areas that get worried about ammonia. So the whole industry is changing by putting in a lot smaller refrigerant charges, modular refrigeration, putting systems outdoors rather than inside the building. So things are changing in all aspects of our industry. Maybe the air conditioning has been a bit more stable. It kind of looks the same, other than the variable refrigerant volume systems that are coming online. That was never heard of years ago, but that's a really, really good thing.
Yeah. No, and I agree too. It's definitely specialized. There's not as much out there. And that's why we see like the different parts of the country or with not that skill level, you know what I mean? You don't see it taught in schools as much too. There's very minimal industrial refrigeration, very minimal supermarket refrigeration, less commercial refrigeration. And then it seems like there's a lot of schools for HVAC, so, yes. And that's what Refrigeration Mentor is trying to do, is get the commercial refrigeration side on. So I really appreciate your thoughts on that. I think we should dive into a little bit more of some of your expertise, because I know you're an expert in industrial refrigeration, commercial refrigeration, and there's a lot of people who want to get better. So we got some slides here. So if you're listening on the podcast, head to the YouTube channel, check out some of the slides that we're going to go through. And I think we should just start about what an installation looks like to you, because you've done them all over the world. In the hottest parts of the world, you're putting ice in, to the coldest parts of the world, putting ice in. Well, why do I put ice inside a building even though it's minus 40 out all the time, right?
Yeah.
So let's talk about a little bit about some of your experience on the ice rink side, and when you're starting a project, what are some of the things you're looking for?
Climate is probably one of the first things technically we look at. That to install an ice rink in northern Manitoba, northern Alberta, it's cold and it's dry, and
I live there, so I know.
There's a lot of benefit with that cold air for sure, but it does have its problems as well. Versus doing a job in Toronto or Florida, where you have a lot higher humidity. And although I would like to say the refrigeration is the absolute most important thing there is to do with an ice rink, it's actually that climate that probably has the biggest impact on these ice surfaces. And if we look at the Calgary Olympics as an example, that Calgary has very favorable weather. It's cool and it's quite dry, where Olympics in places like Sochi on the coast, or the upcoming Olympics in Milan, the humidity is 3 times higher. So that works against you when you're using evaporative cooling, and it definitely works against you when you have to try to keep a building dry. That if you look at the two most critical ice surfaces, I'd like to say, are probably the curling and the long track speed skating. That when you're trying to glide a 45-pound stone down a 150-foot ice surface and there's frost on it, it's just a nightmare for the curlers. But if you can keep the dew point within the building within 2 degrees of that ice surface, it really, really reduces the amount of frost impingement and the mechanical obstruction that frost makes on the ice. First thought, well, why don't we go down a lot lower in dew point? One is it's expensive to do it, but if you get your dew point too low, you'll actually start sublimating the pebbles that are on the ice, and that obstructs the game as well. And long track speed skating, I mentioned. Everybody wants to set world records. That's the big thing. They love to have a world record. But when you're skating 10,000 meters and trying to break a record by a tenth of a second and there's frost in the ice, it's not going to happen. So maintaining that inside environment is important. Now, that's the air side of it. Refrigeration side, you've got to have enough refrigeration to do the work. Depending on how much money your community has, will dictate of how much redundancy you have installed. But nobody can put in 2 plants on a local community arena. So you usually try to size your plant for around 30 to 40% larger than what's required. So if one compressor is off, the second one will handle the load. You might not have perfect ice, but you're not going to lose your ice.
Okay, that makes sense. So when you're going in, the first step, like you said, is that climate. What's happening around the system before we're doing an install? So you get it in, and one of the things is that you said you want to keep that air temperature about 2 degrees above the dew point of the surface. Is that correct?
The dew point. You want to keep the dew point about 2 degrees above the surface.
Yeah, and so if you don't, it's not going to be the nice ice that they want. So this here is. Every rink in the world doesn't need that good, but this is what you want for the best ice. And this is the best of the best. Yes. For the best of the best ice.
Yes.
The thing is, though, is what are they using? And you said it there, is that dehumidification is going to be very, very important. What now with the new technologies like CO2, for an example, we're seeing full integrated systems where we're doing the refrigeration, we're doing the ice, we're doing the cooling in the walk-in box, as well as we're doing the heating of the stands. What are some of your thoughts? Is this going to continue to grow? Because I've seen some out there already. And what is the benefits and disadvantage of going to a full, say, inclusive system, like a CO2 system in a rink? Advantages and disadvantages.
I think it's a wonderful thing that in the old days, we had a mechanical dehumidifier, usually 2 of them hanging in each corner of the rink. And there was electrical service you had to provide to each one of those, and they weren't very efficient. They were an air conditioner being used in a cold environment, which didn't really work very well. You had to operate the coils so cold that they would freeze up, and then you had defrost cycles, which are inefficient. So by having a totally integrated system, you have one box. And that box with the single utilities going into it will do your heating for the ice rink. It'll do your cooling for the ice rink. It'll do your dehumidification, your air handling, your fresh air ventilation, all sitting on one footprint on the pedestal out back or on the roof, one set of wires going into it, and all the energy coming from your ice plant rather than dissipating the energy to a condenser outdoors. So CO2's got the benefit of very high temperatures. So desiccant dehumidifiers operate really, really well the higher the temperature is used for the reactivation process. And that's where CO2 has a real good handle on things, that you can do some amazing work with those high temperatures.
Yeah. Mm-hmm. And I think so too. I think we're going to see more and more of it, but there is some challenges with it, because it's not like you can just go throw one. Like, there's people that are installing them now and working on them. But even though I'm talking to those people that are doing these installs, like, it's still new. Even for the people that have been doing it for decades, it's still new. And you can't just go throw this anywhere. You can't just go put this in the secluded places where you can't get a technician who has those skills.
A couple of interesting aspects of that. One interesting story is we did the University of Alaska in Anchorage, and we did it with indirect CO2, where we had ammonia chilling CO2, and CO2 was being used as a brine pumped through the floor.
Awesome.
One of the big benefits of CO2 in the floor is that it's a volatile brine. It doesn't have a low temperature in and a high temperature out. It creates a monolithic temperature across the whole floor, which is a real big advantage. So nothing to do with the CO2 system, but the people who were putting the dasher boards in were using a forklift with a chain to drop them in place, and they were putting them in section by section. And when they came to the header trench, by mistake, they dropped the hooks down into the trench, and when they lifted the mast up, they ripped off one of the CO2 lines, which was full of CO2. The system was charged, and it wasn't running at that point in time. It was prior to startup, and the pressure was somewhere equalized at around 1,080 pounds pressure. And when that line was broken off, it was like the horns of hell just broke loose in that rink. You've never heard a sound like that in your life. But an interesting thing happened very quickly is when you rapidly depressurize CO2, it turns into dry ice. So rather than continue to vent, the sound went away. It chilled off inside the floor rapidly. And rather than having water in a pipe, which you froze, which would burst it, when CO2 turns to dry ice, it actually gets smaller. So it didn't cause any trouble with breaking pipes due to freezing. So what was done is out in the container, the compressor room, which was an outdoor one, a vent line was open, allowing it to continue to vent outside. The pipe was welded. They were back in business. So they, in the previous year, had a direct R22 system, when there were several hundred of them around the United States where there was R22 pumped through the ice rink floor. So the dean of the school, I had to go to a meeting next day, and he had heard about this explosion in the rink and everybody getting scared. And he said, "Do you really think we've taken the right direction going this way?" And I said, "Well, it's nothing to do with the refrigeration system. It was an accident that happened by another tradesman, and it was fixed. We lost about 1,000 pounds of CO2, which cost about $1,500. I said, "The only difference, if it had been last year with R22, you would have lost $250,000 worth of R22 before we got it stopped." He said, "Yeah, that's a good idea. Let's stay this way."
No, exactly. So there's benefits there. And that could happen with anything, though. You know what I mean? So like the 22, it might not be as loud. I've been in many stores, and this is what I try to talk about in my programs to the technicians. Like if you have a leak in an HFC store, because I've seen it, the whole store goes white. You know, you want to get people out of there. If it's at 404, if it's 22, it doesn't matter. Same with CO2. It's going to turn white. It's a little bit higher pressure. It sounds a little bit louder. I've heard all these pressure reliefs go off, even, 120 bar or 1740 PSI. It's scary. But you know what I mean? It's loud. But if you understand the safety protocols of it, it's just like working on ammonia. People's like, "I don't want to work on ammonia." But if you understand how to properly work on it, you've been doing it for 45 years. You're still here kicking and enjoying what you do. You know what I mean? Yeah. And took your family around the world, and you're still doing it. So it's just understanding the safety. And this is what I push to everyone around the world. We got to be safe and don't get complacent. So even if it is 1,000 pounds leaking, understand how to stop it, evacuate the people properly, and fix the problem, because that's our job as technicians.
Yes. One thing that is a little bit of an issue with CO2, but as long as the rink is big enough, it's not a problem. It's the threshold limit value. And if you go to ASHRAE 34, they'll tell you how many pounds of refrigerant you're allowed per 1,000 cubic feet of airspace in a building. And many of the direct R22 rinks had no problem. And the reason being, you used to be allowed to have 13 pounds of R22 per 1,000 cubic feet. And I have to actually look it up here, but with with CO2, we're down to 1/5 now. We're only allowed 3.4 pounds per 1,000 cubic feet of airspace. So I think what we're going to see happen more in the future is the CO2 systems will be indirect and putting glycol through the floor, or even better than that, doing aqua ammonia through the floor. So the aqua ammonia will still give you a fairly high efficiency going that way, and you won't impact the refrigeration concentration limit in the building.
So that's a good point. Why do you think the regulation with that would it even matter if it was another refrigerant? Why are they going from 13 pounds, you said, down to 3.4 pounds? Is it because the release rate could be a lot faster than CO2, the pressures? Because that's kind of either one are not good for you. You know what I mean? It doesn't matter if it's R22
yes.
or if it's CO2. Both of them are bad. You know what I mean?
I guess you'll almost have to ask the rats that they tested on that. And that's where they come up with it, is they do lab tests with every single refrigerant has a different threshold limit value.
Yeah.
And R22 was fairly good. You could put a fair amount of it in a system, but they find that the toxicity of the CO2 was greater than what the R22 was. But then ammonia, for instance, there's no possible way we could ever put that as a direct refrigerant in a floor. It was done. The last place I saw it done was Aspen, Colorado. It's gone now. It's now an indirect system. And in Ontario, there was a number of outdoor rinks that used a direct ammonia in the floor, but then it wasn't really that much of an issue. So you have to be cautious with which refrigerant you use. And this became a debate in the air conditioning world as well, where they were using common systems to feed all these smaller apartments, that each apartment had access to that quantity of refrigerant. So they had to really watch that they were not over the threshold limit value.
Yeah. And that's it. You got to know your codes and your regulation. Doesn't matter the refrigerant. We have B52 here in Canada, and then there's the ASME regulations. There's so many different ones. So depending on where you're at in the world and you're listening from, dive into those codes and regulations, especially if you're a contractor and you're a business owner. Technician, you still need to know your safety, right? And getting into the codes. Because when I first started out, codes, I've read them, I had to do them on tests, but it wasn't something I was focused on. I was focused on the technical side. Something breaks, how do I fix it? But that code stuff can save you, and save the people around you. And that's why they make codes. Sometimes we don't like them, but it's that people doing the tests and they're saying, okay, this is safe for the public.
It's really interesting that very often you can improve safety and improve the facility operation as well. But for years, we were stuck on using single system, single chiller, single condenser. Having 2 or 3 compressors on a single chiller gave you efficiency advantages when only one compressor was running, same as on a condenser. If you had one big condenser and you were down to 1 of 3 compressors, you had great condensing properties. Your condensing was very low. Then by going to modular systems, we lost some of that. But the benefit of having those modular systems is redundancy. And in the photo group there that I sent, there's a picture of the system we did in Saudi Arabia, where we did 4 completely separate modules. Benefit is that you were never exposed to a breakdown by more than 25% of your system. There was a chiller, a condenser pump, and a compressor on each module. So if one module shut down, you still had 75% redundancy. The other thing is your refrigerant charge is now divided between 4 systems rather than 1. So if you have a catastrophic leak, you lose 25% of your refrigerant. By using external cooling tower, you now have a warm fluid going into the cooling tower, and that warm fluid is the energy supply that you need for doing heat recovery. So you didn't have to put in an extra heat exchanger. You use that warm fluid and take it into either a direct source for heat, like fresh air preheat, or you could use it as a feedstock for heat pumps.
Yeah, that makes sense. But one of the things, though, is that this will cost more than just a signal unit, but it's a redundant and it's a safety factor. So on those critical environments, like anything, like blood banks, I work there, I know people, they're like they got 2 of everything. or like
Yes.
the pharmaceutical. If this piece of equipment costs $1 million, we want one more that's costing $1 million right here. Because if this one goes down, we need this one up and running, because we're talking about billions of dollars of sometimes refrigeration. Because I'm sure you work in some industries like that where refrigeration is so important. Like people, like I keep talking, I tell people I'm in refrigeration. Well, what's refrigeration? But when you think about it, everything that we do today really involves refrigeration. We're talking here, there is some sort of air conditioning or refrigeration cooling the servers that this is broadcast through, things like that. So it's important to understand that. But redundancy can be important. And I kind of seen that over the years, depending on the customer, because they're always trying to cut cost, or reduce cost. I shouldn't say cut, but reduce cost. And sometimes it bites customers in the butt when they go too much. You know what I mean? Have you noticed that your travels over the decades on projects?
Oh, absolutely. That if you go with a single compressor system, single chiller, single condenser, somewhere along the line, something's going to happen that's going to shut that down unless you're continuously onto it doing maintenance. And when that happens, you're out of business. That there's nothing you can do until it's up and running again. And I've never heard a customer unhappy when they have a modular system with several compressors and one goes down. He just gets on the phone and says, I think one of those systems might not be working. And that might not be the case. Sometimes it's just off in thermostat, which we've had happen many times. But having that backup, they're sure thankful for, because there's never a good day for a breakdown. And very often it's always during bad days when there's a heavy load.
Yeah, no, exactly. Oh man, it's just so interesting that all the different sides of industry is very similar. Even when you talk with smaller systems, like in the middle of the summer here, when it gets 40 degrees Celsius, 45 degrees Celsius, and your air conditioner breakdown, like, man, I wish I had a second one. You know what I mean?
Yeah.
So right now, what types of projects are you working on right now? Like, let's talk a little bit about because you got a team, you do installs. What is Accent Refrigeration doing right now?
Well, actually, we do not anymore. 2 years ago, we all retired. There was a bunch of us. We all have been working together within the company for 35 years, and a few of us much beyond that at a previous company. So we've been together forever. Wow. So our last job as a group was in Saudi Arabia, and we had 6 guys who were senior citizens, all of us over 65, 2 years ago, and everybody knew their bit, their piece, their job, and it went so well. And it was building the first professional hockey venue in Saudi Arabia. Wow. And there was about 200 tradesmen on all aspects of the projects from other people, but only 6 of us. And I remember the project manager coming to us and said, if I could find 6 more senior citizens like you guys, I'd fire the other 200 people tomorrow. But it just went really, really well. So that was our goodbye job for all of us. And then me and 2 other people here were involved on the design side, and we've been keeping really busy on that. We're working right now on the 2026 Winter Olympics. We've had lots of jobs across Canada and the US. We're just starting one more job in Saudi Arabia right now, which is going to be a few years out that we're doing design work on. So we're keeping quite busy on the design side. And I'm 68 this year, but I think I'll keep going for another 4 or 5 years and then let the young folks take over. That on our previous business, we had a couple of companies, and one was we were a Thermo King dealer. And we did all the tractor trailers and trucks all over Vancouver Island. We did over 600 of them. Those guys took over on that end of it, and our service guys took over on our service end, and we're just a small, happy group of designers right now.
Oh, I love that. But this is the thing, like inside refrigeration that I tell people, and a lot of newer people in the industry, it can take you everywhere.
Yes.
You started out as in school as not knowing anything about refrigeration, learning, to become a technician, to working as an installer, working as a service technician, which is totally different jobs, and then becoming a business owner, and then learning about design and engineering, and it can take you everywhere. What is one of your favorite things about refrigeration now, and what do you see the future of refrigeration looking like?
I think what's happening is on the heat rejection side of the cycle is the biggest growing part of our industry and probably the most important part of the industry. That prior to now, in the early days, refrigeration was just a big cost to a community when you put in an ice rink. But when you start using that energy and heating the building footprint, and on many venues where they have a double or a triple, or down in Ontario, you've got many fourplexes down there. We've worked on a couple of them down there. There's a lot more heat available that you can share within a community. And that really makes it a paying proposition, without a doubt. Here, where we are, is we have an indoor ice rink, an outdoor ice rink, and a skating trail that joins the two of them in my venue right here where I'm sitting today. Way more energy than what we need for the building. We heat the building, we do the dehumidification, we do the hot water all off the ice plant. But there's still 60% of excess energy. We pump it 400 meters down the road to a housing development, the West Hills housing development. And it goes into their, after their heat pump compressors towards the houses. We don't go directly into the bore field. It started out with 30, 40 houses in the beginning. We had enough heat to heat just about all of them. Now there's over 1,000 homes there. And they get their heat from 3 heat pumps. They're 3 ammonia heat pumps that our company built 12 years ago. And that's where all the heat comes from. So once again, this rink can't do 1,000 houses. So we've got a bore field with 300 holes underneath it. It's a soccer field during it's used, a well-used soccer field. And underneath it's where all the energy comes from to heat all the houses. Europe now, they're eclipsing that. They've got massive heat pumps going in Europe now, just incredible scale. London is about to transform, where they're going to be heating an awful lot of their public buildings. So from the rivers in Vancouver, Shark does so much with sewer heat that they're extracting heat from sewers all over North America. They've done a great job with that. So there's so many clusters around where you have a brewery, you have a grocery store, you have an ice rink, and you have a community that's built around it. I really think that is the future, is harnessing all this energy and having it not go to waste. People don't think of heat as refrigeration, but that's the useful byproduct we have is just using the benefit of the hot side of our cycle a lot better than what we did 30 years ago.
Yeah, it's transferring that heat, because those condensers, big condensers on those supermarkets is, man, when I were just blowing all that heat out, it's just gone. And then I've seen it so many times where like the heat reclaim or heat recovery is just turned off. Oh, well, we don't need it. It's inefficient for our store. And I've seen end users lots of times. I asked the technician, they're like, all these stores have all the heat reclaims turned off. And I'm like, why? Well, the end user says it's inefficient. It costs them more money to run the heat reclaim and heat recovery. I was like, okay, maybe. I don't know. It's free. It can be free, but that's one of the things though. When you have a heat pump, you're using it, all year round. Because I'm seeing a lot more CO2, big industrial heat pumps. You're always running in transcritical, so it doesn't matter. But when we talk about like a supermarket refrigeration, we need all the heat in the wintertime. In the summertime, when we generate all the heat or most of the heat, we don't really need as much. So we're going to figure that out as well. And I continue to see, just like you're talking about there around the world, the people that I deal with and I work with, they're saying more district heat, microgrids starting to make it more efficient and effective than what we did 50 years ago, 30 years ago.
In grocery stores, especially in humid climates in summer, there's a real benefit for desiccant dehumidification to reduce defrost cycles. And if you've got a CO2 system right in your store, you could totally regenerate your desiccant dehumidifier and not pay a penny for heat other than the fan moving the air around.
Yeah.
That's a real good use for it. One of the interesting jobs we did in Boston a few years ago is we used internal combustion engines driving screw compressors. And so your first thought, geez, we're trying to decarbonize and you're using internal combustion gas-powered engines. Isn't that creating more carbon? But in the Massachusetts area, that most of the electricity comes from turbines, gas turbines. And then there's what we call line loss. When you get your electricity, it leaves the plant and arrives at your venue, there's a lot more electricity produced than what actually arrives, just due to step up, step down, and so on. So by putting those internal combustion engines that are driving the compressors right in the rink, we're moving the electrical supply or the prime mover to the compressor rather than using power. But you think, well, internal combustion engines are not really that efficient compared to a 94% electric motor. An internal combustion engine is maybe 50% efficient. So where does the inefficiency go? It's heat, it's waste heat. It goes up the stack. So we did a total heat recovery off those engines, and we used that for powering the dehumidifiers, heating the hot water. Our cooling towers almost never come on there. We're using all the energy within the building. It's a 3-plex rink. It's going to grow into a 4-plex, but it's all done very cleverly and efficiently of using the heat. And we got a big multi-million-dollar grant to do it because they understood the dynamics once we explained what we're doing.
Oh, I love that. Yeah, I know that sounds super cool. I love that. Just hearing the evolution of you, you know what I mean? Because 30 years ago you weren't thinking about this, but now you're in it and you're like, wow, how can we change, make it different? How can we evolve? Because this is another thing I love about refrigeration. It continues to evolve. People think, oh, refrigeration is stagnant. Some people say it's the same as it always was. It's not. It's not. With the new technology, electronics and monitoring and AI, predictive analytics, as well as design. And it's all done in refrigeration. Super exciting. Any final thoughts for the people listening, technicians or business owners in refrigeration?
In my early days, as I said, when I went to trade school, I really, really liked it. And if I didn't do that, I might not have continued education throughout my life, but I liked that small little snapshot in time so much. Almost every year, I would take a course. I took industrial instrumentation in Edmonton. And then I went and took an electronics course. And then I took a business operating course. And then any refrigeration course I could get on in North America and Europe, I would go to. And I think continuing the education, keeping at the leading end of the wave, and really make your future rather than wait for it to come to you. Like, look for opportunities or develop opportunities is even better. That come up with ideas. They might not all work out, but you can refine it. As long as you're all in, you can take your idea and make it better and make sure the customers are happy.
I love that. I think that what you said there is so key. Not only in the refrigeration industry, but in general. You should be investing 10, 20% of what you make into educating yourself to make yourself better. And that's what I do. I every year I'm taking new courses, trying to develop myself, because being curious and continuing to learn only makes us better and the people around us better. So I love that point. Art, how can people find out more about you or learn more about your design and your consulting work?
Sure. www.accentrefrigeration.com, or look me up on the internet, give me a call. I just love the industry. Like, talking about it now is just what I love to do, just with you and with other folks. So we every trade school on South Island and the universities all come here to bring their students for classes, or if the class is too big, they bring us out to their place to do them. So there's 2 of us here that are doing a lot of training for people, and we just do it pro bono to help them locally and get people involved. And Camosun College and Victoria, or the University of Victoria, and Royal Roads, they come to learn about energy efficiency. It's just a fun thing, and you learn from so many people. The people you teach can teach you just as much as you can teach them. Yeah.
Oh man, I love it. Art, I want to thank you so much for taking the time to chat with us here at refrigerationmentor.com, getting on the podcast. And once again, it's taking your time, investing in yourself, trying to get a little better each day, and you can be super successful. Just like Art, he traveled the world. This is what refrigeration is about. If you want to travel the world, you can. If you want to make a pile of money in refrigeration, you can. You want to start your own business, you can. You can do all this stuff. But like Art said, the most important thing is investing in yourself every year. Art, thank you so much for taking the time.